Like examples of a free control volume of a stream tube is steady flow has a uniform inlet rho 1 A1 V1 and uniform exit flow. Find the expression of the net force on the control volume. Okay, we are going to apply this the equation for the summation of force equal to change of momentum, and another term that we can convert from V rho A to the m dot. M dot is the mass rate of change. So we start from the Renault transport theorem. Summation of force equal to, because this term we assume that the change of momentum inside the control volume is 0, so this term is 0. So summation of force is equal to the integration of Cs okay, so for inflow v for point 1 v1 low v1 cos 180 a1 plus v2 low v2 cos 0 and a2. This is cos theta, we got negative, so we got rho v1 a1 and time v1 plus low v2 a2 and time v2. Okay, for rho v1 a1 is equal to m dot 1 v1 plus the m dot 2 v2. Okay, so that is we call it as conservation of mass. So this means that m dot 1 is equal to m dot 2 constant, so we can say that the summation of force is equal to bring in front of the and equal to v2 except v1. Okay, the next question, the problem is a sluice gate across the channel of width B is shown in the closed and open position. That is the anchoring force required to hold the gate in the place larger when the gate is closed or when the gate is open. Okay, so we have two conditions, open and closed. So for the closed gate, we can apply the Renault transport theorem. In this case, we apply this, and for the change of momentum, change inside the control room is 0. Okay, and because of there's no flow on the surface, so we assume that this is 0. No momentum across the surface because it's no flow. So there is only the hydrostatic force. And okay, equal to 0. So we can prove that for the closed gate, the Ix is equal to just the hydrostatic force. Okay, but the next for the open case, is the change of momentum inside the control volume is 0. Okay, so this is only the change of momentum on the surface. So the surface we have v1 at point 1 is 100 cos theta is 180 and area is HB, and for V2 cos HB, okay, that is the change of momentum on the surface, and is equal to the next summation of force. What is summation of force is one is hydrostatic force, subtract Rx, hydrostatic force as downstream, and the friction force at the bottom. And we can substitute equation that can rearrange that x is equal to in this case we assume that if capital H is greater than small h very much and V1 is smaller compared to the V2. Okay, so we can cancel V1 because very small. So we can reduce the equation of Rx into okay, when we compare between this Rx and this Rx, so we can prove that the Rx for if we condition of Rx and for open gate, it should be less than Rx for the closed gate. Okay.